Hey guys, in this video we're going to be working with cosine law. So in the last video we did an example of working with sine law where you're given a couple of the side lengths, or you're given one of the side lengths and a couple of the angle measurements, and you have to find everything else. For cosine law you will be given different information that doesn't let you use sine law right off the bat, and we're going to talk a little bit later on what information you need in order to use sine law and what information you need, or what information you have to be lacking in order to use cosine law. Now with cosine law, all I'm going to do in this video is I'm going to do the bit where you actually have to work with cosine law. In an exam question, I could ask you to solve the triangle, so basically figure out all the sides and all the angles, but make it so that you need to use cosine law and sine law in both of them in the same question. But here all I'm going to do is I'm going to do the bit that requires the use of cosine law, because from our last video you can hopefully figure out how to use sine law to solve everything else. Okay, so there are two different times when you need to use cosine law. One can be to figure out the length of a side. If you remember this formula, small c squared equals a squared plus b squared minus 2ab times the cosine of the angle c. And then if you rearrange this, you can rearrange this by moving the 2ab cosine c over to this side, and it becomes positive. So you get 2ab cosine of c, cosine of big C, equals a squared plus b squared minus small c squared. And then to solve for the angle itself, you just divide both sides by 2ab. So to get rid of the 2ab, you divide it by both sides by it, and it disappears from the left side, and you're just left with a denominator of 2ab on the right side. Okay, so those are the two different forms of cosine law. Alright, so one is to figure out the length of a side, one is to figure out the length of an angle, and I'm going to do one quick example for each. Okay, now the first one is with this triangle shown over here. So you can sketch this out. Basically, you're given a triangle and you've been provided with three pieces of information. You know two side lengths and you know one angle. Alright, so A, we don't know anything for the angle, but we've been told that side A measures to be 8 units, 8 centimeters, let's say. Alright, so this right here is side A. Now, we don't know angle B, but we've been told what side B is, which comes out to 11 units, or 11 centimeters, we'll say. And I've written it off to the side. Angle C, we've been told, is 37 degrees. Okay, so you know two sides and you know the angle in between them, but you don't know enough information to use sine law. In order to use sine law, you would need a pair. You would need an angle and the side that use the same letter. Big A for the angle, small a for the side. You would need both of those pieces of information plus one more piece of information to only need sine law. But if you have angle A, angle B, and side C, then you don't have enough information yet to use sine law. And if you have side A and side B and angle C, then you don't have enough information to use sine law. So this is where we are right now. We have side A and side B and angle C, but we don't have anything else. So we have to use cosine law to figure out side C. So I'm only going to go as far as figuring out side C, and that's where we'll stop for this video. And then we'll move. That'll be the end of this example, and we'll move on to the next example. So here we want to know what side C is. So side C is down here. Down here. Alright, so c squared is equal to a squared plus b squared minus 2 multiplied by the length of side A multiplied by the length of side B times the cosine of angle C. So c squared is equal to, the length of side A is 8, so 8 squared, plus the length of side B, which is 11, so 11 squared, minus 2 I'm going to actually move this down here. I'm going to run out of space. Minus 2 times the length of side A, which is 8, times the length of side B, which is 11, times the cosine of angle C, which we know is 37. Okay, so that's all the information we have. Now, from this point on, it's really all just math. C squared is equal to 8 squared is 64, 11 squared is 121, and then this whole thing is going to come out to something else. And this comes out to, I believe, minus 88, so that would be 176 is just the numbers, 2 times 8 times 11. And then cosine of 37, according to this, comes out to 0.798, approximately. Okay, so most of these numbers, cosine of most angles, sine of most angles, will be these weird numbers. Okay, which is why you should use your calculator. So that's what we're at right now. And all you need to do now is just put all of this together. And if you do all of the math, I have the answer up here, so this is convenient for me. If you do all of this math, so you add these two together, you do that multiplication, and you solve it all until you get one number, you get that C squared equals 44.44 units, but square units. We don't want C squared, we want just C. So you can use your calculator again. You don't want C squared, you want just C. So you write C equals the square root of 44.44. Alright, that's what you put into your calculator, and it should spit out an answer for the length of side C, which in this case is 6.67 units, approximately. Okay, 6.67 centimeters, let's say. Okay, so that is how you can use the information that's provided to you to get an answer for the last piece of information. So you'll have either side or angle A, either side or angle B, and side or angle C. But you won't have side and angle A and little a. You won't have side and angle B and B. You'll only have one piece of information that's got A as its label, one piece that's B, and one piece that's C. But you won't have multiple ones, because if you had multiple ones, then you can just use sine law. Now, the second case where you will need cosine law is when you're trying to figure out not the side, but the angle. Alright? So, in this question, we were trying to figure out the length of side C. So now we're going to do a slightly different example and try to calculate angle C, given different information. So now in this case, we're going to have a triangle that looks something like this, where this is up here, this is angle A, this in here is angle C, and over there is angle B. Okay? Now that means that down here, this long side down here, is going to be side little a. Okay? This side over on the left is going to be side B, because the angle is all the way on the opposite side, and this side up top is going to be side C. Now in this question, you are provided with the side lengths of all three sides, but you are given no angles. Alright, so you are told that side C measures to be 8 centimeters, side B measures to be 5, and side A is 9. Okay? So this is the information that you have, and now I'm asking you, give me angle C. That's the information I want. Now, we start with the original equation, C squared equals A squared plus B squared minus 2AB cosine of angle C. You rearrange, bring this over to the left side and make it positive, so you get 2AB cosine of C equals A squared plus B squared minus C squared. and then you divide out 2ab, because we don't want the rest of it attached to cosine c. So we're left with cosine of c is equal to a squared plus b squared minus c squared divided by 2ab. Okay, and this is what we are working with now. Notice that all of this stuff on the right side is just side lengths, and we have all three side lengths. We have a, we have b, we have c, and then in the denominator we just need a and b. So we get cosine c is equal to, well, side a is 9 units, so that means 9 squared. Side b is 5 units, so plus 5 squared. Side c up here is 8 units, so we subtract 8 squared divided by 2 times 9, because that's the length of side A, times 5, because that's the length of side B. And you can do that math, and it'll give you 9 squared is 81, 5 squared is 25, so that right there is 106, minus 8 squared, which is 64. Alright, so 106 minus 64, that's what, 42? Yes. And then in the denominator you have, well, 2 times 5 is 10, times 9 is 90. So you have cosine of c. Now at this point you could try and, get a number at the top and a number at the bottom and figure it out by yourself, or you can just take all of this and plug it into your calculator. 81 plus 25 minus 64, get an answer, divide it by 90, and you get you get some number, right? So basically what we have here is if you add up all the stuff at the top, then you get that cosine of c equals 42 over 90, all right? So that's where we are right now. Now, to get from this to just angle C, this is where you need that second function button on your calculator. So you have to hit that second function button and hit the cosine button. So instead of saying cosine, it'll say cosine inverse. So the way you would write that is you write angle C by itself, not attached to cosine. Angle C by itself equals cosine inverse. So like an exponent of -1 is how you would write it. That's not what it means, but that's the notation. Cosine inverse of 42 over 90. Okay, so the 42 over 90 comes from this that we had on the other side of the equal sign. But this is the notation. This is how you would write it down, and either your calculator will say cosine inverse, or it might say arc cos instead, which is the same thing. Okay, so you can write cosine inverse or you can write arc cos of 42 over 90. Both of those are correct. And then your calculator does the rest of the work for you. You write cosine inverse, open bracket, 42 over 90, close bracket, and it will tell you that angle C is 62.2 degrees to 1 decimal place. Okay, so that's the answer to this. When you're given all three sides and no angles, this is how you can go about solving it. Now, how do you know when you need to use cosine law versus sine law? So if you notice, sine law is built for equating one fraction to another fraction, right? Sine law has sine A over little a equals sine B over little b, and the same for sine of C and little c. Basically, in order for this to work, you need to know one fraction entirely. You need to know both big A and little a, plus you need to know one of big B and little b, so that you only have one thing left to figure out from this. Or, if you're not working with B, big C or little c. But you need, from one of these fractions, big A, big B, big C, little c, you need both pieces of information for one of those fractions, and then you can solve the rest of this using sine law. So basically, if you're given angle A and side length A, you can use sine law, as long as you're given a third piece of information. In all of these questions, you'll be given at least 3 pieces of information, but it depends what those pieces of information are. So if you're given 2 pieces of information that both have the same letter, angle A and side A, then you can use sine law. Angle B and side B, you can use sine law. Same for angle C and side C. But if you're given 3 pieces of information and none of them share the same letter, so you're given angle A, side B, and angle C, then you don't have enough information to use sine law, and that's when you have to turn to cosine law. Okay, now I'll try not to confuse you when it comes to a test question. If you have to use cosine law, because we've been working so much with finding angle C and side C, I won't change the letter names. I'll make it so that you're still trying to find side C, because otherwise you have to rewrite the whole equation and it starts to look different, and that can just get confusing really quickly. But basically, if you don't have both pieces of information that share the same letter name, then you have to use cosine law. So if you don't have both angle B and side B, you can't use sine law. You have to use cosine law. So you'd have one piece of information from A, either the angle or the side, one piece of information from B, one piece of information from C, then you have to use cosine law, and you'll always have enough information to use at least one of the 2 options. Alright, so hopefully that all made sense. In the next video we'll explore something a little bit different, but if you have any questions, then let me know.